Hello, everyone. I want to talk about topic 2 of our FAML course that we will be starting soon. Let me say that again, yeah? Before I go on, let me welcome all of you to this video. I'd like to tell you about topic 2 of our FAML course, which we will be starting in a few weeks' time. I just want to give it an overview, right? What are the things that we'll be talking about and so on. In a previous video, I told you about topic 1, where we talked about survival models and the things that we'll be covering. Yeah. So I want to tell you about topic 2. What is topic 2? Topic 2 will be life tables and selection, right? Okay, this will be our topic. It's chapter 3 in the Dave Dixon textbook, our recommended text. And we'll be going through all the ideas presented in the text. Okay, we'll be going through all the ideas presented in the text. We'll work some problems given in the text. Okay, we'll work some problems given in the text and some exam questions and so on. So let me tell you what basically, not all of it, just some of it, right? Some of the ideas that you'll see in this chapter. When you talk about life tables, yeah, most life tables, right? Most life tables are presented as, okay, are presented at integer values, right? Let me write that again. Integer ages only, yeah? Okay, let me say it again, right? Most life tables are presented at integer ages only. What does that mean? That means we are looking at, let me draw a timeline here. X, okay, x plus 1. These are all integer ages, yeah? X plus 2. Let's say we go right up to x plus t, okay? So life tables are presented at integer ages only. And so what we want to do is we also want to be able to not only talk about probabilities and stuff like that at integer age values, but also at ages between integers, right? We also want to deal with what happens here, and so on. What that means is, in addition to what happens at age 30, 31, 32, and so on, we also want to know what happens at age 30.75. So this is in between integer ages. So we want to figure out how to deal with those things, yeah? Probabilities and stuff like that. So while we're at this, we will see some notation that we saw earlier in our previous chapter. Okay, one of the more common ones that we'll be dealing with will be TPX, which will be LX plus T over LX. Okay, so we're looking at LX, LX plus 1, yeah, LX plus 2, and this will be LX plus T. Yeah, these all number of lives observed at age X, number of lives observed at age X plus 1, number of lives observed at age X plus 2, and so on, right? Okay, number of lives observed. Technically speaking, right, it should be expected number of lives. I didn't say that, right? Technically speaking, I should tell you it's the expected number of lives at age X, expected number of lives at age X plus 1, and so on. So just to make things simple, let's just say LX is the number of lives at age X, number of lives at age X plus 1 is LX plus 1, number of lives at age X plus 2 is LX plus 2, and so on, okay? So we will learn things like DX. DX will be the number of deaths, okay? So between age X and X plus 1. So this will be LX minus LX plus 1, okay? The number of lives here minus the number of lives here. Okay, the number of lives here minus the number of lives here will give you what? The number of deaths that occurred between age X and X plus 1. Not too bad, right? So this one we can also write it as, if you know probabilities, right? We can write QX as equals to DX over LX, we'll also see things like this, yeah? Qx equals to dx over lx. What is Qx? It's a mortality rate, right? The probability of dying between age x and x plus 1. Just count the number of people who die between x and x plus 1 and divide it by the number of people you started with, which is lx. You get Qx. Okay, so we'll be working with things like this, yeah? And let me also tell you, right, that we have, when we deal with, like I said, right, we want to be able to work with ages between integer values, right? Like age 30.75 or age 31.6. We want to be working out probabilities, etc. Yeah, for ages 30.6, 30.75, etc. How do we do those things, right? Now, we will cover that in this chapter. We will cover that in this chapter under something called fractional, okay, age assumptions. Yeah. Okay, fractional age assumptions. So how do we do those things, right? We have to worry about, let's see. There will be two assumptions that we'll be working with. One is UDD, the uniform distribution of deaths, and you'll have your constant force assumption. Again, this, I repeat, when you talk about fractional age assumptions, we are talking about age between integers, right? Between x and x plus 1. So we'll be looking at x plus s. Okay, so not too bad, right? We want to talk about these things, right? We have x and we have x plus 1. And let's say we want to find the probability, right? Somebody age 30 will live for another half a year, right? Okay, so we want to find somebody age 30 will live for at least another half a year. So now then we are looking at, we need to use this, one of these assumptions to be able to work these things out. So the UDD, right? UDD, the uniform distribution of deaths. The assumption, well, they've given in two forms in our textbook, right? Let's just use one of those. Okay, SQX will be equals to S times QX. Okay, this will be the assumption under UDD, uniform distribution of deaths. Yeah, SQX will be S times QX. Okay, where S is between 0 and 1, like I've indicated here. Okay, like I've indicated here. So under constant force, right, we will say the force of mortality remains constant. Okay, this is the constant force of mortality, right, where we will say that the force of mortality does not change between integer ages, right? So we will have formulas like, okay, the famous formula is what? Good. TPX equals to e to the power of mu t. Okay, constant force of mortality, again, let me tell you, we are saying that the force of mortality doesn't change between integer ages. So one of the famous formulas, TPX is e to the power of minus mu t. So if t equals to 1, then px will be equals to e to the power of minus mu. So what we can do is we can write TPX as e to the power of minus mu, okay, minus mu all raised to t, right, from here. What is e to the power of minus mu? Px. Okay, this will be raised to the power of t. So you'll see all these formulas. I didn't write too much, but I think when I was thinking of what are the things that they say to you, these are things you'll see in my class. Yeah, this is just an overview. For example, let me just go ahead and write a few things here. You will learn in my class, right? This SQX here equals to SQX. We will write it as, okay, Lx minus Lx plus S over Lx, okay, will be equals to S times Lx minus Lx plus 1 over Lx. So this is something that we'll write, yeah? We know this is a probability, right? So if I have, okay, if I have X and I have X plus S, So this will be Lx, and this will be Lx plus S. So if I want to find the probability somebody age X dying before X plus S, I just write down, yeah, the number of deaths that happened here, which will be Lx minus Lx plus S, divided by the number of people we started with. Okay, and we started with how many? X. So that takes care of the left-hand side. Then I have S times this. Okay, Qx will be what? Number of deaths between X and X plus 1, which is Lx minus Lx plus 1 divided by Lx. So when you clean this up, right, you can cancel this. Okay, when you clean this up, you can write, you can sort out the algebra yourself. I'll show you how to do those things. Yeah, you sort out all the algebra and all that, and finally you'll get. Let me write it here. Okay, Lx plus S equals to 1 minus S Lx plus S Lx plus 1. This is not hard to see, right? Because when you cancel this, can you see this Lx plus S? I've moved it to the right hand side. This S times Lx, I've moved it to the left. So I have Lx minus SLx. Can you see this one here? And then I have a minus Lx plus 1. If I move it to the left, it becomes plus. There you go. Okay. Okay. There you go. So it's not so bad, right? Remember, there's a bracket here, right? There's a bracket here. So that's how you get these things. Now, the point that I'm trying to make is you'll see that this allows us to do what? Yeah, we can do linear interpolation when we have, okay, when we are using the uniform distribution of deaths, okay, when we use the uniform distribution of deaths assumption, we can do linear interpolation, yeah, and get through quite a few of those things. So besides that, what else? We'll also be learning what? One more thing. We'll be learning about select and ultimate probabilities, yeah. Maybe I should use the word mortality, yeah. Okay. Select and ultimate mortalities. We'll be looking at things like what? We'll be looking at things like when you get selected at age X, and then let's say you have a 3-year select period, 3-year select period, you'll have X plus 1, and then you'll have a X plus 2, and then finally you have a X plus 3. Okay, your select period, right, wears off after 3 years if you're looking at a 3-year select period. Okay, 3-year select period. I'll tell you about all those things in detail, right? So this is just an overview, telling you what are the things that we can expect. I'll tell you a little bit about, okay, the easiest thing I've said so far is, in this section will be the constant force of mortality assumption, right? Between integer ages. Very easy to use the formulas. And otherwise, I think this chapter is not too difficult. Let's see. The chapter here is based on some of the things that we would have covered in survival models. So it should be plain sailing. Yeah. Okay. Thank you very much for watching. I hope to see you in my classes. We'll be starting on the 29th of April. Please do join me, right? Thank you very much for watching.